yes, it was a homozygote.
They had two of the
Two affected neurons got
But
married.
if there were two parents that neither one of them knew they had CADASIL, different mutations married, what would that mutation look like in
I
the
know.
child?
It actually it was on the more severe side. In that individual, it was difficult to demonstrate because there was only one patient, but it was on the severe side, which supports actually what we're saying. So to wrap it up, the idea is, remember how we were building up on the idea. The idea led to experiments in vitro. The experiments in vitro led to animals analysis, and then the animal analysis is to clinical trials. So what I'm telling you is this paradigm, okay, that is ill-defined. Never, it became a paradigm for whatever reason, and it helped us. But I don't think it's necessarily what is at the core, at the heart of the problem. I think that what is going on is that the NOTCH3 mutations that lead to CADASIL actually affect NOTCH3 signaling, and if it affects it a little, you get CADASIL, but it's late onset. If it affects it a lot, you get early onset. And this is under this idea is that I am, following through with future studies that can lead us to the cure, because we know. You remember how I was telling you what the cure would look like? The cure would look like something here on Earth that will increase our ability to hear the defective receptor. And no one has to go up there and fix it. We don't need astronauts or anything. We just need to do that. If we can amplify, and we have amplifiers for other things, we can amplify this defective signaling, even if the receptor is wrong, we might be able to actually delay the onset of the disease, and that, for a lot of people, will mean a cure or quite a relief. That is what I mean. So how do we do that? And this is, don't think I'm going to end it there, because this is where we are right now. But where do we want to go? Where do I want to go with this? This is what follows. If we know this is the new idea, this is the new concept, we actually have now the means. You see how it was before at the bottom? Now we can put the idea on top. We can say the idea, the new paradigm, is that NOTCH3 signaling is defective, and then from that I can move forward and I can say, well, can I do in vitro studies? A lot like the ones that I showed you before, and we have the tools to do that experimentally. Okay? Can we do in vitro studies to rescue? And now you know what a rescue is. It's when we get that thing from the Russian satellite to rescue it. It does the same, sends the signal. We can do in vitro studies to rescue signaling or amplify the signaling, and see how that affects. It actually turns out that we can rescue it because we can look at these different data. We can look at this data in a different way. I was showing you the data like this, going downstairs, signaling is becoming smaller. Now I can show you the same data and go upstairs. I can say, well, look at this patient, has 2 copies. Can I rescue signaling by putting more Notch3? Well, if I put one normal copy, which is what we call the wild type, WT, I increase it, didn't I? I did. So, can I do that even with the mutation that is most severe? I have here too. Let's go upstairs. When I put a copy of the wild type, even in the presence of the other one, I can rescue it. It goes up. How many years is that? You know what I'm talking about? Okay, so this in vitro assays is not saying, I'm not even saying next year. This is something that can happen. I'm not saying 5 years. This can be done now. Now I can say, now, can I get now in vivo studies? The mice. Can I rescue the phenotype in the mice by playing with Notch3 signaling? Do I have to make the mice? No, I have them, I made them. They are like crawling around in the cages. So what we can, and we have the phenotypes. So what we can do is to increase Notch3 signaling, to rescue or amplify Notch3 signaling, and we have the tools. We have the means to actually increase Notch3 signaling in mice. We have other mice that express satellites that, or you know how a satellite sends a signal and then it does not? Or we have satellites that send the signal all the time. We have satellites that don't even have to be up there, they can be down here. And here I'm talking just molecular stuff, that the details are not relevant. What I'm saying is, for Notch signaling, for Notch doing something with an alien, we have nothing. For Notch signaling analysis, we have all toys to play with. Because it's been around for a long time, so we know how to play with it, the mice are there, or someone else has it. We have, it's not, you know, it's feasible. So we can get this in vivo studies in mice, and we can rescue and see how they behave. Can we rescue the phenotype in the mice? Can we, now for instance, the arteriopathy doesn't happen. The small muscle cells don't die, this and that. Those experiments I have. This, I guess, I have done at some level. This I have not done. But the tools are there. And now, clinical trials. I can tell you that we are very lucky. Maybe Christy knows about this. Notch is important for many diseases. One of them is cancer. And not just one type of cancer, many types of leukemia, skin cancer, brain cancer, many types of cancer. And that has been known for a while, so much so that many biotech companies have been developing drugs to manipulate Notch signaling. In most cases to decrease it, but also in some cases to increase it, which what we would like. But there is a lot of knowledge built up in the biotech world into developing not one, not two, not three, even four. There is a very strange link between, believe it or not, Alzheimer's and CADASIL. And this is because some of the most important genes that are important for Alzheimer's are related to Notch. And I'm not going to get into that, but I just want to tell you that a lot of biotech companies have been developing drugs for Alzheimer's disease that actually manipulate and have effects on Notch. So there is a lot. I cannot tell you, well, there is a drug out there that increases Notch3 signaling, and then if you give it to people, then you'll be cured. No. I mean, it's not that maybe they have it, but we don't know about it because this is not a lot of ways how biotech company work. But pharma works. But there is a lot of, there are current efforts by not one, not two, but dozens of biotech companies